Hello and welcome back. Today we're going to do 4 the rational root theorem, or the zero theorem. Right? Remember that roots and zeros are the same thing, just where the function crosses the x-axis. We are going to get into finding zeros now that aren't just quadratics and aren't just easy to factor and find. So how do we do that without guessing every number in the world and trying it out? Okay. So the rational root theorem tells us that if we have a rational, or if we have a polynomial equation, okay, we can use the factors of the constant, the number without a variable, and the factors of the leading coefficient, the number of the highest power. And if we divide those factors by each other and make a list, we can find out possible roots to try. Right? I'll show you exactly what this means. So here's our example. All right. So we're going to start with the factors of p, which is this number. So this is our constant. Our factors of 5 are 1 and 5. So what things make 5? Okay. The bottom is the factors of the leading coefficient, which is 1. And those are 1. It's all the things that make 1. So our possible answers for this equation are plus or minus 1 and 5. Or we could do -1, 1, -5, 5. So those are possible roots. Okay. If it's a rational number. So what we're going to do is we are going to use the, we've already used the rational root theorem. So now what we're going to do is we are going to use synthetic division, and we're going to try out these numbers and see if any of them work. Okay. So, actually, no, I'm not. We're going to use last lesson. Last lesson said that if we plug any of these numbers into our equation and it comes out to being equal to 0, then we know that that's a root. Okay? So I'll just pick one. I'll start with -1 because it's the first on my list. So I'm going to go -1 in case I need more, and I'm going to plug it in. So -1 cubed is -1 plus -1 squared is 1 times 8 is 8 plus -16 plus 5, and that's going to equal -8, -9 plus 5 is a -4. So I would say that that one doesn't work. Okay? So -1's not a possibility. I'll just go down my list. So I'll plug in a 1. So I'll have 1 plus 8 plus 16 plus 5. That's going to be a really big number. So I got 30. So that's a no. Okay, let's try -5. So I'll have -5 cubed plus 8 times -5 squared plus 16 times -5 plus 5, and I'm going to plug that to my calculator. Okay, make sure that for like the squared units, any even units, that negative sign gets inside of the parentheses. And then in this unit here, this piece will be a negative. So when you solve that all out, you come out with an answer of 0. So we know that -5 is one of our factors. Okay. So what am I going to do? I'm going to synthetically divide a -5 out of this equation. So I'll have a 1, 8, 16, 5. Okay, I'm going to bring this down. So then -5, because we do multiply and bring it up. And that's a 3. And that's a -15. And that's a 1, -5, and a 0. So my new equation is, so what we just did is we have an x plus 5, because that's this piece here, and an x squared plus 3x plus 1. All right. So you could take a look at this and try and factor this. You could complete the square. If it was me, I would probably just right off the bat throw it in the quadratic equation. So that would give us -b plus or minus the square root of b squared plus 4ac, so 1, 1, so it's just 4. And this, whoop, I messed up. This is a minus. Okay. All over 2a okay. So this is 2 of our answers, plus and a minus version, and then -5 is another answer. That's 1, 2, 3 answers, and this needs 3 answers, so we're done. Okay. The way we had to do this before, instead of having a list of things to try, we had to just try numbers. So that's why this theorem is helpful. All right. The next thing that we also have that can be helpful is Descartes' rule of signs. Descartes' rule of signs tells us how many roots you can expect and which type, okay? So it tells us how many possible positive or negative roots there are, so it helps us in our hunting of roots, okay? This one up here was really easy because we only had 4 things to try, but you could end up with a list of 20 things to try, and that becomes a lot harder. The nice thing is, get the equation into your calculator, and then you can just sub numbers in to try and find that 0, okay? All right, so find the number of possible real roots. Real zeros are roots, and the number of possible negative real zeros for this equation, then determine what they are, okay? All right, so what we're going to do is we start with the regular equation. So we'll start with f of x equals 2x to the 5th plus 3x to the 4th minus 6x third, 6x squared, 8x plus 3. Okay, now we're going to look at sign changes. So from here to here, does the sign change? Positive to positive, that's a no. From here to here, does the sign change? Positive to negative, that's a yes. Here to here, yes. Here to here, positive, negative, yes. Here to here, yes. Okay, so this tells us how many options of positives there are. So we have a 1, 2, 3, 4. So when we do these, they go in pairs. So we have a possibility of, actually they're not going to go for surely in pairs. So we have a possibility of 4, okay? We'll take a look, we'll go back to that when we do the negative. So f of -x, what we're going to do is we're going to plug a negative into here to see if it stays the same. So I'll have 2 plus 3 times -x to the 4th minus 6 times negative x to the third. And let's just simplify that. So negative to the fifth will be a negative. That negative's going to go away. Negative's going to come out. Negative's going to go away. Negative is going to come out. Okay, now let's look at our sign changes. So we go negative to positive. So that's a yes. Positive to positive. It's a no. 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 Okay. So we only had one change. So we know there's only a possibility of one negative real root. Okay, so then we got to look at our options up here. So if we could have 4 positives and 1 negative. Okay, we could have 2 positives, 1 negative, and 2 imaginaries. Remember, imaginaries have to come in pairs. Or we could have 0 positives, 1 negative, and 4 imaginaries. Okay. Why this? This helps us to figure out what our roots are. Okay? All right. So now what we're going to do is we're going to come down here and we're going to look at the factors. So we're going to look at the factors of 3 over the factors of 2. So the possible factors of 3 are 1 and 3. So what things multiply to make 3? The possible factors of 2 are 1 and 2. So that means our possible factors would be 1 over 1, which is positive 1 or negative 1. 3 over 1, which would be positive 3 or negative 3. 1 over 2, so 1/2, or 3 over 2. Okay, so that would be our list. Another way you could write it, which I'm okay with, I just didn't want to confuse you, is you could write plus or minus 1, 3, 1/2, 3/2. So that means we need the positive and the negative of all these are possible options. So now what we're going to do is we're going to plug some numbers in. It looks as though we have 1 negative. So I'd maybe pick a negative and start there. Okay. So whatever. So maybe we start with a -1. We'll start there. -1. And we'll plug that in. Okay. So if we plug that in, we would have a I'm going to use my calculator. So I'm going to grab it really quick. Okay, so instead of doing these all by hand, I'm going to grab my calculator and plug this bear in, okay? So I'm going to start with a -1. So I'm going to have 2 times -1 to the 5th power. Make sure those go in parentheses. 2 times -1 to the 4th power minus 6 times -1 to the 3rd power plus 6 times -1 squared minus 8 times -1 plus 3 Okay, so that answer is 24. So that looks like a no. So now let's try out, looks like a -3. Try those instead of fractions. So I can just do second entry, go change all those -1s to a 3. And that equals 0. Sweet. So that means that we know that this equation is x plus 3 times something. Okay. So what we're going to have to do is factor that -3 out. Okay, I'm going to do it on here just because I'm going to run out of room on my paper. So I'll have -3. Okay. So the nice thing is that we only have to do this when we know we have one. It's +3, -9, +3, negative. Uh-oh. Just making sure I wrote it down right, because it's not coming out right. Oh, that's a -3, so that's a +9. So that's a 1. It's -3. That's a 0. Okay, so this is, it was to the 5th, so this is 2x to the 4th minus 3x cubed plus 3x squared minus 3x plus 1. So I'll write that down. Okay, so that's our one negative, so we don't have any more negative possibilities. So now we just need to try out some positive. So I'm going to start out with a +1, since that'll be easy. So get my equation back here. Yes, I know that this is a lot of work. Okay. That's why you won't have oodles of homework assignment on it. And, oh, sweet, that one came out to be 0. So this is 0. So now we know that we have x plus 3 and x minus 1 times something. So I'm going to take this right here, and now I need to use my 1. -1, -1, 2, 2, -1, -1, 0. Awesome. So this was to the 4th, so this is going to be to the 3rd. Minus x squared plus 2x minus 1. So this is what goes right here. Sweet. So now let's try another one. So let's try +3. Okay, the thing that is rough, well, in this situation, it's not going to be a big deal because we know that this is still to the 3rd power, so there has to be a positive in here still, instead of an imaginary. Okay, the problem would have been is if we would have tried everything in the 4th and it came out to having no zeros, then we would have 4 imaginaries, which we couldn't find with this rule, with this method. Okay, so let's try out a positive 3. See what happens. 600. Okay, so that one didn't work, right? So let's try out a positive. Let's see, 1/2 next. Maybe I'll get the one with negatives back so I can do 0.5. Okay, think of ways that we can work. We can do less work. Okay, oh, that's 0, sweet. So that means that we know that we have x plus 3, x minus 1, x minus 1/2. We got to find out what that quadratic is to find our last two. Okay. All right, so I'm going to set this up again. 2, -1, 2, -1. We knew our number was 1/2. So bring the 2 down. 2 times 1/2 is 1. 1/2 times 0 is 0. 1/2 times 2 is 1. So I have, remember, bring down a power, 2x squared plus 0x plus 2 equals 0. So we'll put that here. 2x squared plus 2. Okay. So then the last thing we need to do is we can solve this. So when you get to the point there's a quadratic, you could use the quadratic equation. In this example, there's no x, so we can just solve for that. So we'll have 2x squared equals -2. At this point, we know that even if we keep solving, this is going to be an imaginary number. I can keep solving for you, but we're going to have the x equals plus or minus I. And if we go back to our original question, it said determine the rational roots. So we only want the, we don't want the imaginary, so we don't care about this point here. So our rational roots right here are -3, 1, and 1/2. So we'd have -3, 1, 1/2. Those are our rational roots. If it wanted all the roots, then we could keep solving, and plus or minus I are our other two roots. Okay. This rule of signs, it is helpful because it helps us eliminate, once we got the negative, that we can move on to our positives. The problem is sometimes you end up with more, it'll tell you have more negatives, so you have to keep going on that way. But it gives you an idea of where to start from. Okay. Use your calculators to plug your equations in. It'll help it go so much faster. Let me know if you have any questions, and have a great day.